Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today on a very rainy day to bring you lesson number 44 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That is straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Raphael kit for Raspberry Pi. The Sunfounder kit for Raspberry Pi. Most of you guys probably already have your gear. If you don't have your gear yet, look down in the description. There is a link over to Amazon and you can pick this kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what we're going to be talking about is we're going to be talking about the sort of next segment of this class. Now, up until now in this class, we have gone through most of the key components in this kit. And what we're going to start with, starting with today's lesson, is we're going to start using the little camera, okay? And the little camera is actually the most exciting component in the Raspberry Pi kit. And it's the one that I've been super eager to get to. But this is what the issue is. We, at the point that we started this class in lesson number 1, at that point, the mainline operating system for the Raspberry Pi was the Buster operating system. The Buster was a 32-bit based operating system, and really we've just been going through what, 44 lessons now. That's 44 weeks, and in the intervening time, Raspberry Pi has moved from the Buster as being the mainline operating system. It is now moved to Bullseye. Okay, so there's been like an operating system upgrade while we've been making these classes. Well, for the things that we've been doing, really the old operating system was fine. It was fine to be using the legacy Buster system. And even if you did those lessons on the new operating system, the Bullseye, everything would work pretty much the same. Now, this is where the difficulty came in. When they moved from Buster to Bullseye, they completely changed the way that you interact with the camera. But when they went to Bullseye, initially there was no support for the camera. And so I found myself in a very difficult situation of knowing what to do. Do I just teach you how to use the camera on the legacy system, on the Buster system, and then everything works as always? It's easy. I know everything I need to know and I can just teach you. What is the problem with that? Very quickly, you go from a legacy operating system to deprecated libraries and things that break and things that don't work the same. So for a class that people might be watching, not just today, but a year, 2 years, 3 years down the road, I didn't want to build the class based on an obsolete operating system when it comes to the camera. So, okay, then just move to the new operating system. But then I had the problem that if I moved to the new operating system, there was no support for the camera. So for the last 44 weeks, I have been trying to find a solution, and I think I have a solution. I'm going to kind of share it with you today. And the bottom line is I'm just going to sort of today show you where we're going in the future. And so you guys that are coming in later, I'm not going to really teach you how to use the camera. You ought to just hop on over to lesson 45, which is next week's lesson, where I'll show you how to install the libraries and put the camera on and do all that sort of stuff. But for you guys that have been going through this class, I'm kind of showing you where we're going next, and I'm showing you why we are going there. Okay, does that sound good? I hope it sounds good. It is indeed quite rainy out there, and guess what? This is the dry season. If this is the dry season, you wouldn't believe what's going on in the rainy season. But anyway, let me jump over and just kind of show you. So what I decided was that we were going to go ahead and upgrade to Bullseye. So what you need to do for next week is you need to go ahead and download a Bullseye operating system. I am using the Bullseye 64-bit operating system, and if I'm not mistaken, the Bullseye 64-bit operating system should run on either the Raspberry Pi 4 or it should run on the Raspberry Pi 3. Now, up until now, 32-bit, 64-bit, I really didn't care. Why did I not care? I really didn't care because if you're measuring temperature and humidity and making one measurement every 5 seconds and sending that back to your PC, speed is not your problem. Speed is not the issue. But at the point that we're going to start doing some really cool things with the camera and we're going to do some video processing and some image processing, speed does matter. So there will be distinct and noticeable advantages to being on the 64-bit system. So tomorrow or next week, the lesson that I'm going to show you in lesson number 45 is going to be built on the Bullseye 64-bit operating system. And so you guys have between now and next week's lesson to flash a card with that operating system, get your desktop set up the way you like to have it set up. If there's any old software that you kind of like on there, get your system up and running and configured with 64-bit. Now you should know how to do that because I showed you how to flash a card and do all that sort of stuff in lesson 1 of this. If you're just coming into this lesson and haven't been through the earlier lessons, you need to go back and catch up on a few of the earlier lessons. So that sounds good. So where I am right now is I am booted up in Raspberry Pi Bullseye operating system in 64 bits. One thing I noticed with this is things are just a lot snappier. Like I noticed the desktop runs a lot better, especially like firing up a browser and looking at the web. Everything is much snappier. So yeah, the 64-bit, I am seeing some perceptible advantages in going to it. So we've made decision number 1. Do we move forward with Buster or do we move forward with Bullseye? We move forward with Bullseye. Then Bullseye is available in either 32-bit or 64-bit edition. We've made decision number 2. We're going forward with Bullseye 64-bit, okay? And now we've got to make the decision of how do we operate with the camera? How do we interact with the camera? Now there are 2 options, and the first option that I'm going to show you is the option that we are not going to use, okay? But I'm just going to show you that it's there. And what you can do is you can come up, and if you open up a terminal, and I need to make this readable for you. No, I don't, because I'm just going to tell you guys know how to do this. You're going to do a sudo raspi config like that, okay? And now the raspi config comes up, and you see that you can come down to interface options, select that, and then you can say enable or disable legacy camera support, and then you can come in and say enable legacy camera support, and then I'm going to say yes, okay? So that says okay, and now I was already on legacy support. If you just move to legacy support, it's going to make you want to reboot, but I didn't want to sit and make you wait through a reboot, so I'd already set this up. And so now where we are is we are on legacy. Legacy camera support. Now you guys that have been through my Jetson Nano class or my Jetson Xavier class or my AI for Everyone class, you have already been introduced to OpenCV and how to interact with a camera in OpenCV, okay? When you enable the legacy camera support, everything works just like it did in the past. And so again, I haven't showed you yet on the Raspberry Pi how to install OpenCV. I'm going to do that next week. Next week, I'm going to show you how to plug the camera in. I'm going to show you how to install the libraries, and I'm going to show you how to fire up and run your camera for the first time. And you can see here, if I look over here, you can see that the way I have it, I have the camera plugged into the Raspberry Pi. Just a heads up, guys, I have found that these little cameras are somewhat static sensitive, and I found a lot of them are fairly easy to blow out. And so once you take the little camera out of the static bag, you want to be very careful. Like don't touch the leads. You want to kind of ground yourself. You just want to be careful with it because you can fairly easily burn these things out. I've lost a few cameras along the way. And then it plugs into this little CSI slot here. Notice that the little blue label points towards the Ethernet ports, and so that's how you know which direction the blue label points in here. And this is a standard connector. You just pop the plastic up on both ends, you press this down in it, and then you press the little plastic bar back down. I'll show you how to do that next week. And then what I like is I have this goofy little tripod, and I just tape the camera to the goofy little tripod. So you see I already have this hooked up, but I will show you more in next week's lesson how to do it. And then what I did was I installed OpenCV, which I will show you how to do next week. And you see that we can operate this camera in 15 lines of code. We import the CV2 library. We set the resolution. I've set it at 1280 by 720. And then what I do here is I don't think I need import time. I'll get rid of a few lines of code there. Okay. What I do is I set up a camera using cv2.video capture, and I show the path to the camera /dev/video 0. Then once I've connected to the camera, I do these CV2 commands to set the display width, which I set here, and set the display height, which I set here. Now I just set up a loop where I go out and from the camera, I grab a frame. And then I create a window I call NanoCam, and I show. So I grab a frame, show a frame, grab a frame, show a frame. And if you grab frames and show them in proper sequence, what do you end up with? You end up with, wait for it, a movie. Okay, so you see I've got live video here coming from the little Raspberry Pi camera. And if you look at that, wow, that is like, let's look, you know that right here, me down here in the corner, the little me is in real time, and then this is coming off the Raspberry Pi. And you can see 1, 2, 3, 4, 5, there's virtually no detectable latency at all. And so we are getting a super great video stream coming from the Raspberry Pi. And then I've got it set where I can just click Q, and then I can leave this. And so this is legacy, how we would do things. For you guys who have not used the camera yet, you can see that I'm going to teach you how to use it, and you're going to be up and making that camera sing and dance in under 15 lines of code, and it's very easy to understand, and this is the way that we used to do things. Okay, now this is the problem. If I teach you how to do things using the legacy camera, everybody is going to be moving away to the new camera, and this is going to have the same problem. It's going to become obsolete very, very quickly. So this is a way to do it, but it is not the way we're going to do it. All right. So what I'm going to do is I'm going to kill this program. And then what I'm going to need to do is I'm going to need to turn off that legacy camera support. So I will come back here again. Trying to get a terminal. Okay. I'm going to do a sudo raspi config like this, and then I'm going to come down again to interface options, enable camera. Do you want legacy support? No, because when you enable legacy support, you disable the modern camera tools. Okay, you disable the modern camera tools. Okay, so legacy camera support is disabled. All right, and this time we are going to have to reboot. Would you like to reboot? Yeah, let's go ahead and reboot, and we'll come over and we'll look at a beautiful view of the river here on this rainy morning. Look at a beautiful view of the river on this rainy morning as we wait for the Raspberry Pi to reboot. Good news is 64 bits will reboot pretty quickly. So what do you guys, as a reminder, what is all that you need to do for next week is you need to have your 64-bit card flashed, and you need to be able to boot in 64-bit, and then you need to go ahead and make the adjustments that you want to make to your desktop and get everything configured the way that you want it configured in the way that you enjoy having things work. Okay, we're now rebooted, and so I'm going to come back to Thonny, and so I will come back to Thonny. And this time, I'm going to come up with this program, and this is still an OpenCV program, but now we interact with the camera differently. In the legacy on this operating system and the old way back on Bullseye, the way that you did it is you had OpenCV call a method. You would call a method in OpenCV to go out and grab the frame from the camera. So you load the OpenCV library, and then there you set up the camera, and then there is a command in OpenCV where you go out and you grab a frame in OpenCV, and then you show the frame in OpenCV, and then you grab a frame in OpenCV. With the new method of interacting with the camera, you are not able to have OpenCV go out and grab the camera. But that's okay. Go out and grab the frame. That's okay, because the 64-bit operating system gives you a command, a Python command, that allows you to go out and grab it. It's just not an OpenCV command. So let's go through this. So what is it? This is still at its core an OpenCV program. So we're going to import OpenCV. I don't think I need to import time. I'll take that out. Okay. Now, besides importing OpenCV, we are importing a library called PyCamera2. That is the library that talks to the camera. Okay, and so what I do is I create an object, PyCamera, and now I've got to set some configurations. Like, remember earlier we did like a cam set this, a cam set that in OpenCV. Well, now we will set those parameters not in OpenCV libraries, but in this PyCamera2 library. And so what you can do is I set the size here of the image. I do a preview configuration.main.size. I set the size, and then I set the format for the image. I do this command called align, which just says pick the natural screen resolution the closest to the one that I ask for, and that way if I don't ask for exactly the right camera size that it likes to use, it will pop to the one that's closest to it. And then what I do is I've created this preview parameter here, and then what I do is I configure the camera with that preview parameters that I set up here, and then what do? I start the camera. Now what is happening? The camera is just sitting there running, but it's not going to do anything because the camera is just sitting there running. The camera is operating, it's grabbing frames, but nothing's going anywhere. Well, what we do here then is we create a while true. I don't need that line of code. And then what do? I grab an image, but I don't grab it with an OpenCV command. I grab it with a PyCam command, and the command is capture_array. Now OpenCV has a frame from the camera that it grabbed using the PyCam library, and now I issue the CV2 command of showing the image. All right, and then what this is just saying is wait, and if it sees the Q key, then quit. So this is just a clean way to exit the program. So let's run this thing and see if it works. It gives you all that red information down there, but it's not. Boom! Ha! Giddy up. Look at that. Okay, so again, that is a very, very nice resolution. And let's see. 1, 2, 3, 4, 5. No latency at all. A nice, big, crisp, but beautiful image that is showing that we can now make the Raspberry Pi camera work on the new operating system the new way. Now, the only thing that's really different for you guys that are familiar with OpenCV, the only thing that is really different is just setting the camera up and then how you grab the frame. Everything else that you know about OpenCV, all of our ability to do artificial intelligence, all of our ability to manipulate the image, all of those things we can still do, but we just set up the camera and grab the frame differently. Also, if there's some reason that you absolutely have to do it the old way, all the lessons that I'm going to teach you should work on the old system. Let me come back over here. Should work on the old system. It's just what would you do differently is that how you set up the camera and how you grab the frame. And so if for some reason you're in some unique situation that you're forced to proceed with either the old operating system or the old mode of interacting with the camera, your code will be exactly like my code in all of these next 20 or 30 lessons, except for you will be setting your camera up like this, and you will be grabbing your frame like this. But now once you have that frame, everything else is going to be the same. Guys, I am sorry that I have sort of taken a lesson just to get this straight, but it's been this thing that has been a really, really big deal. And it's been this thing that I've really, really wanted to be moving off into the camera portion of this class, but I just couldn't find the right path. Now I have the right path. We are on the new operating system. We are interacting with the camera the new way. Excuse me. The new operating with the camera the new way on the new operating system. And so this thing that I'm showing you should be working for the next years and years and years and years. All right. And so I'm just trying to think that there are two groups of people that are taking the class, the people that are taking it right now with me as we go along in real time like today. And then there's those people who will be coming in 2 years from now. And so I'm talking kind of like to two different points of time at the same time as I speak. But what I've put together here will work now today in my time, but also should work for people who want to take the rest of the class in the future. You guys, give me feedback. Does this make sense, what I'm saying? I mean, do you kind of understand why I took today to try to get you guys normalized? Do not install OpenCV. Do not try to get ahead of me, okay? I've told you the operating system. Install the operating system, and then next week I will show you how to install OpenCV so that everything will work the same for us. It'll work the same for me, and it'll work the same for you. You guys that are doing this in the future, make sure that you install my version of OpenCV, the version that I'm showing you to install. Make sure that you install that, even if in your time in the future there's these more future versions of OpenCV. You need to be using the same version of OpenCV that I am. In that way, everything should work. Okay, guys, I hope this was okay with you. I hope that you're not frustrated that we didn't make the normal progress that we make in a class, but this is a new point. It's kind of like a new section of this class, and I wanted to take one class period to just sort of introduce to you where we're going and why we're going to do it. Now, we are going to be doing some exciting things. Like, what's one thing that you see right now based on the last few lessons that we had that would be cool? It would be cool that if you could incorporate this camera with your security system, so that if your security system sees something, if it sees motion from your PIR sensor, you could go out and turn the video on and you could capture some frames or some still images of what triggered the sensor. So you see right off the bat, boom, this thing would be really, really cool to be using using with that security system that you guys are working on. And so that's one thing. And then the second thing is that this is just going to open up. We're going to get into, just the basics of using the camera. And then we're going to start getting into some pretty cool artificial intelligence things that you can do with the frames that you're grabbing that, it's sort of like, when you look over here, let's see if this is right. No, that's not right. This is it. So what you see is that you are grabbing a frame and then you are showing a frame. But between grabbing the frame and showing the frame, this is the magic spot here. And we can do anything that we want here. And even though we're grabbing frames at 30 frames a second, what we have is a 30th of a second between those two lines of code, and that is a lifetime at the speed that computers operate. So there is all types of mischief that we can do between those two lines of code. And this is where we're going to be doing our artificial intelligence, and all the neat and cool things are going to be between those two lines of code. So that's what's going to be the next, probably, I would say, wouldn't be surprised if we have another 20 lessons or so on this particular topic. And then the cool thing with the Raspberry Pi is when you see something and then you understand something by analyzing the frame. Now, because we have those GPIO pins, we can go out and do something. We can move a servo, we can send a message. There's all types of things that we can do based on what we see in the frame. Okay, guys, I hope, give me feedback. Did I just make you mad? Was this lesson a waste of time, or does it kind of help you understand where we're going and why we are going in that direction? If you guys like this lesson, be sure to give us a thumbs up. If you haven't already, subscribe to the channel. When you leave a comment down below, that really helps us a lot with the old YouTube juice. And then make sure that you share this video with other people, because the world needs more people doing coding and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.